Hello, everyone. My name is Yolanda Jones Thomas. Welcome to our channel. In today's video, we are going to discuss pitch. Whether you are a student learning about computed tomography, better known as CT, for the first time, a healthcare professional looking to enhance your skills, or just simply someone interested in medical imaging, this tutorial is for you. So grab your notebook and a calculator and let's get started. Let's define pitch. Pitch is a key parameter in helical spiral CT. It is defined as the ratio of the table feet per 360 degrees of tube rotation to the width of the X-ray beam. How does pitch impact patient's dose, image noise, spatial resolution, and coverage? A pitch of 1, the table moves exactly the width of the beam per rotation. This is referred to as balance pitch, typically yielding optimal image quality and dose. As you can see here, there are no gaps in slices, also no overlapping of slices. For a pitch less than 1, in this example 0.8, at this pitch, the patient moves in the gantry slower than a pitch of 1. The table moves less than the beam width per rotation, resulting in overlapping slices. Pitch less than 1 results in a decrease noise, increase image quality, spatial resolution, but also patient dose is increased. Decreasing the pitch will also decrease the amount of anatomy covered per total acquisition time. For a pitch that is greater than 1, in this case 2, the table moves more than the beam width per rotation, resulting in gaps between slices. There is an increase in noise, a decrease in image quality, spatial resolution, a decrease in patient dose, a decrease in scan time. Increasing the pitch will result in more anatomy being scanned lengthwise for a given acquisition time. Upon first glance of the previous image with a pitch of 2, it might appear that the reason for the decline in image quality with the increased pitch is due to skipped or missed anatomical data. That is not true. In fact, although there is a smaller amount of photons being collected per rotation, data is still being collected. To grasp how pitch affects the image quality, imagine pulling the ends of a spring. As you can see here in the image, the coils begin to slant as stretched by the pull. Likewise, as pitch increases, also the slice angle increases. Additional interpolation is needed to straighten the slant and maintain image quality. However, if too much interpolation is used, it can result in a reduction of image quality and introduce artifacts such as blooming of the effective slice thickness. Slice thickness and pitch. Single detector CT versus multi-detector CT. For multi-detector CT, the beam collimation and slice thickness are no longer the same. As you can see here, in these two images for the multi-row detectors, the thickness of the X-ray beam is divided into rows of detectors compared to the single slice CT scanner, in which the thickness of the beam is the thickness of the final slice. For instance, if the beam collimation is set to 5 millimeters, then the slice thickness is 5 millimeters. For multi-detector CT scanning, the thickness of the X-ray beam is divided by the number of rows of detectors. In this magnified view, you will notice there are 4 slices per gantry rotation for this multi-detector CT scanner. If the beam width is 5 and there are 4 slices per beam width, the thickness of each slice would be 1.25 millimeters, compared to the slice thickness of 5 for the single detector CT scanner. Multi-detector scanning allows for thinner slices capabilities and higher spatial resolution. By optimizing slice thickness and pitch, multi-detector CT scanners can achieve superior imaging quality with reduced scan times compared to the single detector CT, making multi-detector CT a preferred choice in clinical practice. Therefore, for multi-detector CT systems, the pitch is commonly called beam pitch and defined as the table distance traveled in one 360-degree gantry rotation divided by the total thickness of all simultaneously acquired slices, known as our beam width, where beam width is calculated by multiplying the number of slices by the slice thickness. Review of commonly used pitch formulas for both single detector CT and multi-detector CT. For single detector CT, it is the table traveled divided by the beam collimation. For multi-detector CT, table feed divided by beam width, whereas the beam width equals the number of slices times the slice thickness. Now we are going to solve for a few pitch problems. Problem number 1. During an exam, the table traveled 3 millimeters in one rotation and the beam collimation was 4 millimeters. What is the pitch? Compared to a pitch of 1, will there be an increase or decrease in patient dose? It may be beneficial for you to pause this video, work out the problem. Once you have completed the problem, continue the video to check your answer. Now that you have solved for the problem, let's discuss. Before solving for this type of problem, I use the following strategies. I determine if it is a single detector CT or a multi-detector CT word problem. To determine this, I look for keywords. In this case, table traveled and beam collimation. This lets me know that this will be a single detector CT word problem. Then I compare the table traveled to the beam collimation. The table moves less than the beam collimation per rotation, resulting in overlapping of slices. I expect my answer for the pitch to be less than 1 and there to be an increase in patient dose. So we have a table traveled 3 millimeters and the beam collimation 4 millimeters. Our answer is 0.75 pitch. Now, compared to a pitch of 1, will there be an increase or a decrease in patient dose? There will be an increase in patient dose as expected. Problem number 2. During an exam, the table traveled 6 millimeters in one rotation, and the beam collimation was 5 millimeters. What is the pitch? Compared to a pitch of 1, will there be an increase or decrease in patient dose? Try the strategies and solve for the word problem. It may be beneficial for you to pause this video. Solve the word problem. Once you have completed the problem, continue the video to check your answer. Now that you have solved for the word problem, let's discuss. Once again, based on the key words, which are table traveled and beam collimation, I know that this is going to be a single detector CT pitch word problem. The table moves more than the beam rotation per collimation, resulting in gaps between the slices. So I expect there will be a decrease in patient dose. Here we have our table traveled 6 millimeters. Our beam collimation is 5 millimeters. That gives us a pitch of 1.2. There will be a decrease in patient dose. Problem number 3. For a certain protocol, a table feed is 120 millimeters per second. The scanner is 32 slice and slice thickness is 2.50 millimeters. What is the pitch? It may be beneficial for you to pause this video, solve the problem. Once you have completed the problem, continue the video to check your answer. Now that you have solved for this word problem, let's discuss. Let's apply the strategies. So we have keywords table feed, also slice and slice thickness. I know that slice and slice thickness is needed to find the beam width, as we discussed earlier. Therefore, we know that this will be a multi-detector CT pitch problem. So we find the beam width, which is the number of slices times the slice thickness, which give us a beam width of 80 millimeters. Our pitch for this particular problem will be 1.5. Thank you for joining me in this tutorial on CT pitch concepts and word problems. I hope you found the explanations and examples helpful in understanding how pitch affects the quality and speed of your CT scans. If you have any questions or need further clarifications, please leave a comment below. I'll do my best to respond and assist you. Don't forget to like this video if you found it useful and subscribe to this channel for more tutorials and tips on medical imaging and radiology. Also, make sure to hit the notification bell so you won't miss any of our upcoming videos. Until next time, please feel free to connect with us on any of our social media platforms.